Hello students, so the purpose of this video is to get you acquainted with compound inequalities as well as disjoint inequalities. So when I'm solving a compound inequality, I want to find the individual inequalities first. And then if I'm joined by the word and, then the solutions are the values of the variable that simultaneously satisfy each inequality. So we're looking at an intersection. We talked about intersections in one of our previous sections in this chapter. And if two inequalities are joined by the word or, then the solutions are the values of the variable that satisfy either inequality. So we're looking at unions. Remember in math that there's a difference between intersection and unions. When I say and in mathematics, so if I say I go to Walmart and Target, it means that I have to do both and there's no other option. If I say I go to Walmart or Target, in math it means I can go to just Walmart, or I could go to just Target, or I could go to both. And so that's considering the union. So we're going to start out by looking at ORs first. So ORs are pretty self-explanatory because you're literally given two inequalities. So I'm going to go ahead and put a box around these for you. But you're given your first inequality, which is the x minus 2 is less than or equal to 5. And then you're given your second inequality, 1/2 x, which is greater than 6. So you see you got your first inequality here, and then you literally have another inequality there. So I guess I shouldn't have used yellow. You're not going to be able to see that. So I'll use green for the first inequality. I'm going to add my 2 to the other side, and that was super easy to solve. I end up getting that x is greater than, or excuse me, x is less than or equal to 7. On this other inequality, I want to get rid of the fraction, so I'm going to begin by multiplying by 2 so that I'm left with just x, which means I need to multiply the other side by 2, and that leaves me with x is greater than 12. And so what's interesting is that if I put this on a number line, so I have the number 7 and the number 12, for the very first inequality, x is less than or equal to 7, I care about the value 7 and all the values that are smaller than it. And then for the second inequality, I do not care about 12, but I'm looking at all the solutions to the right. So when you have OR statements, it's interesting because a lot of times your solution sets are going in opposite directions, and that's why we call these disjoint inequalities. We don't want to put them together. However, when I use the word and, I can actually put the solutions together. So if you notice in each of these inequalities, they both have the 6x minus 1 portion. And in the first inequality, 6x minus 1 is bigger than -3. And then in the second inequality, it has to be smaller than +3. And we're using the word and. So that's telling us that we can actually write this as one inequality, 6x minus 1. And it needs to be less than 3 and at the same time greater than or equal to -3. And so now that we've written this as a compound inequality using the word and, we can actually solve this together as one inequality. Okay, so it's kind of up to you if you want to solve the two separate inequalities and put the solutions together at the end, or if you want to go ahead and solve them together, while it's written as the compound inequality with the and. It's really up to you. I'm going to go ahead and solve it with it all written together. So again, my goal is going to be to get this 6x by itself and then eventually to get the 6 by itself. So I need to get rid of 1, so I'm going to add 1 so that goes away. And the only difference is I'm going to add 1 to the other side, but now I have 2 sides I have to add it to. And that leaves me with -2 is less than or equal to 6x, which is less than 4. And again, I'm trying to solve for x, so I am going to divide by 6. But if I divide by 6 in the middle, that means I need to divide by 6 on the right as well as the left. So I'm going to divide every term by 6. -2 divided by 6 gets me -1/3, which is less than or equal to x, which is less than 2/3. And when you write your final solution, you want to ask yourself, does this make sense? Can I find a number that is both bigger than negative 1/3 and at the same time smaller than 2/3? And if you can, then you can keep it written as one inequality. And I can put this on a number line and mark my negative 1/3 and my positive 2/3. I can create my circle. So I'm going to have a closed circle on negative 1/3, an open circle on 2/3, and I'm going to shade in between.